Friends, here we are given a rectangle A, B, C, D, right? And in this rectangle, there is an isosceles right angle triangle A, B, E, right? And when they say isosceles right angle triangle ABE, that automatically means AB is equal to BE, right? Because this is the rectangle, so angle B is 90 degrees. So obviously, A angle opposite to 90 degrees will become the hypotenuse. So there is no question of AE being A equal to AB or A equal to BA because this is hypotenuse, this is the longest side. So obviously the remaining two sides will be equal. So AB is equal to BE. Right. Now, this BE is one third of EC. Right. EC is equal to three times of BE. That means BE is one third of EC. Now, if we draw a line like this and complete this rectangle, for example, if you draw a line like this rectangle, and let's say if you call this EF, right, then ABEF, this rectangle is one fourth of total ABCD. Why? Because B is one third of EC, right? So that means this rectangle is will be one third. This is one times, and this is three times. This FECD will be three times of ABEF, right? So the total will be 4 and this is 1, this is 3, right? 1 is to 3, right? So what is the area of this triangle ABEF now? This is this is a diagonal now. We don't need to worry about isosceles right angle triangle and all, right? ABE is actually half of ABEF. If this is 7, this is 7, this is also equal to 7. So ABF will equal 14. What does that mean? The total ABCD will become 4 into 14, which is equal to 56. This is such a simple problem. We don't need to worry about area of isosceles right angle triangle and all. Right. Just by looking at the construction, we should decide that this is an isosceles right angle triangle and this is half of this rectangle. This rectangle is actually one fourth of the overall rectangle. Right. Thank you, guys.